If you are also looking for professional certified structural engineering services or courses, then don't forget to check link in description of this video.
In this lecture, we will learn about the finite element method for slab design. Finite element method is utilized by Etabs as an alternative method to design slabs. In this method, you will have to use the reinforcement contours provided by the Etabs output to add the slab reinforcement. Code requirements for the detailing and anchorage of the reinforcement remain same as per as the choice of code of reference. For example, in our course we are using ACI code, which is an American code for concrete and reinforcement detailing. For ACI code, the anchorage length minimum is 12 times diameter of the bar from the point where the reinforcement is no longer needed. This point we will practice in further. Addition to anchorage requirement, the detailing requirement from ACI code are shown like this. So if you are using the ACI code and you have to detail the reinforcement, whether there are extra reinforcement or the primary reinforcement. So for example, in the top rebar, the 50% bar should be at least 0.3 times of the clear span on both the sides. And similarly, if the extra reinforcement requirement is required, so it should not be less than 0.2 ln. The code recommends at least 50% of your bar should be 0.3 ln and the remaining can be 0.2 ln, means the clear, let's say the clear span is ln, which is also shown in ACI code diagram. This snapshot is from ACI code chapter 8. So the top reinforcement of the slab should not be less than 0.3 times of the clear span, and similarly for the bottom reinforcement in the column strip, it should not be discontinuous, so the bar should be continuous 100%. However, for the middle strip, if you are using the strip method, you know how to design using the strip method, as we already covered the strip method in our Etabs Udemy course lecture 27. So in the middle strip, you know that we can have discontinuity in the bottom reinforcement in order to have cost saving. The discontinuity in the reinforcement is provided to have cost efficient method of the slab design. So for the column strip, bottom reinforcement should be continuous, and for top reinforcement in the middle span, you can have 0.22 ln, 0.22 ln. However, most of the time in design office practices, in order to simplify the design method, we can take this distance conservatively as 0.3 ln as well. So that would be a conservative approach, and you would also be fulfilling the code requirements. While for bottom reinforcement in the middle strip, at least 50% should be continuous throughout, while the remainder of the reinforcement can be at a distance of 0.15 clear from the center of the middle column. So in this lecture, we are mainly focusing on reinforcement design of RCC flat slab, considering the same 20-story building design which we did in the Udemy course of Etabs. Design of reinforcement slab of the story 1. Calculate slab thickness, calculate thickness of drop panels, calculate drop dimensions. Design of slab reinforcement, check slab thickness by deflection, check drop panel thickness by punching shear check. However, these all points are already covered in lecture 27 of Etabs Udemy course. So I'll be skipping all these points. If you want to revise these points, you can reverse the course and go back to lecture 27 in order to calculate all these points. Specific detailing requirements for beams and slabs based on code include the following and must be referred on emphasis, since the emphasis of this course is how to design using Etabs. Minimum and maximum reinforcement to be allowed, minimum maximum shear reinforcement allowed, punching shear detailing requirements and joint requirements, minimum maximum spacing criteria, minimum maximum distribution of the rebar spacing criteria. This also is already covered in chapter number 27. So first let's go to the Etabs and see what we got there. So this is the same model I am using in the Etabs. So instead of story 1, Now I'll be designing the roof slab. So for the first step of FEM method, you have to define the load combinations which are already defined in our model. You can add default design combinations and click on concrete slab design and click OK. Since the combinations are already added, so I pressed cancel. Then go to design, concrete slab design, and view revise preferences. Then you can go to minimum cover of the concrete slab. The first thing you have to check here is the factors utilized in the code. These factors are selected based on the code which you are using. For me, I'll be using ACI 2019 code. So there are additional parameters involved. If you edit any parameter, it will change the color to red, and if the black is means you have already changed this value. Okay, minimum cover for the slab. For our slab design, we'll be using minimum cover as specified by ACI 2019 as 20 mm. Preferred bar size, it can be number 3 bar. In American standard, this bar would be dia 10 bar. So this is a SI system bar. And then you can define the minimum criteria for slab reinforcing is two-way, because our slab here is two-way slab. We already discussed in detail the difference between the one-way and two-way slab in our lectures. However, the main point of the course is to emphasize on how to do the analysis and design using Etabs. Let's click on OK and then go to analyze and click on set load cases to run. Click on run all and then run the analysis. In the meantime, when the analysis is run, we can check the minimum reinforcement required for the slab. Since the minimum reinforcement of the slab required thickness of the slab, the formula to calculate minimum slab reinforcement as per ACI code is 0.0018 into 12. Since the minimum slab reinforcement per fit RB is being calculated, because we are calculating the minimum slab steel area requirement per fit, so we are using 12 inches in the formula. 0.0018 into 12 into the thickness of the slab. So the thickness of the slab is 8 inches, so our minimum reinforcement for the slab to be provided per fit is 0.178 inch square. Spacing for number 3 reinforcement, or you can say dia 10 reinforcement, is equals to rebar area into 12 inches divided by minimum slab reinforcement. So the rebar area is your choice, whatever you are using. For example, I'll be using number 3 bar. So if I plug in the values into the formula, 0.11 into 12, which is from the formula as we are calculating per fit, divided by the minimum slab reinforcement which we already calculated as 0.1728. So the spacing of the number 3 bar is coming out to be 7.63 inches. So in order to round this value, we will provide 7.5 inches of the slab reinforcement. Now let's go to the analysis results, whether this mesh is being able to satisfy the requirement of the slab reinforcement or not. So if it's not meeting the minimum requirement of the slab reinforcement, then we'll have to provide extra reinforcement.
If you are also looking for professional certified structural engineering services or courses, then don't forget to check link in description of this video.
Okay, so our analysis is complete now. Please note that since we are using the same model which we used for the strip method, or you can say the direct design method, so strips are already drawn. For this method, you don't need to draw any strips. For example, if I even delete these strips from the model, there would be no difference in the analysis and design results. So I'll go to concrete slab design and select stories for design. So I'll be designing the roof slab, and then I'll click on start design. For this one, first we have to check the design combinations are already added, which they are. So okay, I'll go to design and concrete slab design, start design. As we already calculated, the minimum area of steel required for this 8-inch thick concrete slab is 0.1728 inch square per feet. So first thing is we have to fix the units of the model in order to match the calculation of the minimum steel which we provided. So let's go to the units, go to show units form, go to rebar area. Okay, first we have to change the consistent units into inches, which is already changed. Okay, click on OK, and then go to units and show units form. Now I'll see rebar area per length. You can change it to inch square per feet, and similarly this one inch square per feet, because we are plugging in the values of 12 inches into the formula. That means the area of reinforcement we are calculating from the formula is for per foot requirement. You can use the same methodology when working in millimeter or meter units or SI system. Click on OK. Now I'll go to this design, concrete slab design, and display flexural design. You can also do a quick check on the punching, since we have already performed punching check for this slab previously. So you can go directly to the flexural design. One important thing to note is for the punching design, when you had revised preferences, go to design, concrete slab design, view revise preferences. When you change the preferred bar size, the punching shear ratio would change, and the reason for this one is when you are manually calculating punching shear, also the reinforcement area or the rebar diameter is utilized for this calculation. In order to calculate the effective depth, the reinforcement diameter is an important factor. If you have performed manual calculation for this one, you can refer to manual calculation from any book, as the purpose of this course is to emphasize on Etabs. Now let's go to the concrete slab flexural design. Okay, so since by default it's selected strip method, as we have already drawn strips, but for this right now we are focusing on the finite element method and click on impose minimum. First of all, we have to understand what is the direction 1 and direction 2 in Etabs. Direction 1 is X direction. Direction 1 means your bar will be horizontal reinforcement, and direction 2 means your bar will be vertical reinforcement. Right now, since we are not using strips, so I'll hide the strips as they are irrelevant for this method. So our minimum area of reinforcement was 0.176, and click on apply in top direction 1. Okay, so the contour is showing wherever this mesh is sufficient. Mesh means if the complete reinforcement is provided for number 3 bar at 7.5 inches, so this is covered in all the area which is purple. However, the blue colored area means that the reinforcement requirement is higher than number 3 at 7.5 inches. Okay, so in this blue colored region we have to provide extra reinforcement. So I'll pick randomly one area and then we'll detail the reinforcement for that area only, because the main point is to learn how to design using Etabs finite element method, and we are not supposed to complete this whole design in one video as it would take a lot of time. So let's say I pick this drop panel and I want to design the extra reinforcement for this drop panel only. So I'll go to top direction 1 rebar, which means the horizontal reinforcement, and then click on apply. 0.176, I repeat, is already applied for the mesh. So minimum reinforcement for the slab we are providing is 0.176, which means we are providing already number 3 at 7.5 inches center to center. So I'll add this one in drawings. For showing the mesh reinforcement in the slab, usually we are representing like this. So this shows that we are providing a mesh. So you can put this mesh at anywhere in the slab and give a leader line to specify that this mesh is. Mesh reinforcement means this reinforcement is continued in both directions and top and bottom. So number 3 at 7.5 inches center to center means this reinforcement we are providing as a minimum reinforcement in both the directions as per the minimum thickness requirement of the slab. Now we are supposed to calculate the extra reinforcement for the FEM method. So let's say for this contour we have to design the extra reinforcement for this drop panel only. In order to save time, I'll just design the extra reinforcement for this drop panel. One restriction for us is that whatever extra reinforcement we are providing, so it has to be multiple of 7.5 inches. So in order to simplify for the site, I'll make this 7.5 inches as 7 inches because measuring half inch is not an easy task on site. If you have visited civil engineering sites, it's not easy to measure 7.5 half inch value inside. And also if we are providing the extra reinforcement in multiple of 7 inches, so it would not be easy to provide the reinforcement. So extra reinforcement will be added in slab like this. For example, this is your main continuous reinforcement and you wish to provide additional reinforcement, so the additional reinforcement will be added in between these bars. So this would be your additional reinforcement like this one. So these are your additional reinforcement and this is the continuous reinforcement. This one is in plan view and just for demonstration purposes. So basically if we are providing extra reinforcement also number 3 at 7 inches, so it means the actual distance between the bars would be 3.5 inches. So that's why we are providing 7 inches rather than 7.5 inches, because if we provided 7.5 inches and the extra reinforcement also number 3 at 7.5 inches, so the spacing actual between the bars plus the extra bars would be 3.25 inches, and quarter inch is not an easy task to measure on site when providing the reinforcement spacing. So let's check in the model if we can work this out with extra reinforcement of 7 and number 3 at 7 inches. So I'll just increase the intensity to 2 and see the effect on the contour. Still I'm getting dark blue color, and dark blue color means I'm exceeding the extra reinforcement value from this number. So let's calculate if we provide number 4 bar at 7 inches, would it cover this area? So you can hover the cursor on the contour also and look at the bottom left. So the bottom left is showing me that this area would be working within 0.8 and 0.89 inch square. So if I add 0.88, okay, 0.88 is still less, so let's add randomly 0.95. We'll check this number just in a moment. If this dark blue color vanishes, it means that my reinforcement would be sufficient, extra reinforcement. Let's make it 1 inch square, 1.1. Okay, it seems that almost 1.1 inches or 1.15 inches would be sufficient. Okay, so let's calculate exactly. For example, if I am providing number 4 bar, so the formula which I'll be using for calculation of the rebar area is exactly the same. Rebar area into 12 inches divided by the spacing. Since spacing for us is now already fixed based on 7.5 inches. Sorry, we changed this number to 7 inches because of the reason explained already due to site execution difficulty. So this number for now, the minimum slab reinforcement which we are providing as a mesh reinforcement is 0.188 inches, which is number 3 at 7 inches. So I'll revise this number in Etabs. And then go back to the formula. So now we are interested in getting the area for extra reinforcement. So according to Etabs, 1.15 inch square per feet is almost sufficient for extra reinforcement in X direction for the top reinforcement. So if we use this formula according to this one, we need to let's try number 4 bar. Let's use 7 inches. It's still less than 1.15 comparing to Etabs requirement. So I'll increase the diameter of the reinforcement to, let's try number 6 bar. And please note that since the mesh reinforcement is already present in this location, so you have to add the mesh reinforcement as well. Okay, so it is still less than this one. So I'll go to number 7 extra bar. Number 7 has an area of 0.6 inch square. So number 7 at 7 inches is plus. Number 3 at 7 inches is satisfying the requirements above this top panel. So for the extra reinforcement, our calculation is while we provided so in bracket I'll add the reinforcement area with exact numbers to clarify further. So the reinforcement area for number 7 at 7 inches is 1.0285. And the reinforcement area for the mesh which is already provided is 0.188. The provided extra reinforcement plus mesh is 1.2165. So I'll add this number in Etabs 1. Because the rounding up was done due to the availability and spacing requirements of the bar. Now the next step is we have to calculate the length of the bar. So the length of the bar depends upon two factors. I'll take the screenshot here. Let's draw dimension lines. I'll roughly pick the maximum point where the contour is changing the color. So this bar is approximately 132 inches. Okay, so it is 132 inches, and now I have to add additional for the code requirements. So in order to add the anchorage length, I'll take a screenshot here. The rebar in X direction would be actually like this, and plus the anchorage length. The anchorage length as per ACI code, since we discussed it already in the beginning of the video, is 12 dB, and this length will be provided in both the starting and ending location of the bar. Anchorage length means the minimum distance of the reinforcement in the concrete in order to develop the full bar capacity and bonding with the concrete. So in our case, the anchorage length will be 12 times diameter of the bar. Diameter of the bar is 7 by 8. So it's 10.5 inches. So let's add it into the extent of Etabs. 10.5 plus 132 plus 10.5. So the total bar length will be 153 inches, or you can round it up to 160 inches. So let's model this reinforcement in AutoCAD. So the reinforcement length rounded up is 160 inches. Now move it in center of the column. Let's see the dimension. Okay, so it's 160 inches bar. We will provide the labeling as well, but first we need to see another thing is, which is the extent of this distribution. So the extent of this distribution would be, draw a dimension line. So it is extending up to 186 inches. In feet, 186 inches would be 15.5 feet. So for reference, I am giving this line. This dimension was just for demonstration. Usually we won't show it in the drawings, as the contractor would add it in the shop drawings already by himself. Okay, now we have to label this extra reinforcement. For that, we will add number 7 at 7 inches center to center, extra top. Okay, so this is how we added reinforcement as per Etabs FEM method following the code requirements of ACI. Additionally, you need to check the requirement of the code from this table as well. For example, if your 50% bar is extra reinforcement, so it should be not be less than 0.3 ln in column strip. So this rule applies to FEM also, since it's a column strip. So 0.3 of 24 feet on both directions we have to provide. So 0.3 into 24 is 7.2 feet. So 7.2 feet in both directions we have to check. 7.4 feet from the face of the column at least. So I'll add a line and give an offset of 88 inches. So this is now detailing requirement. We already designed this reinforcement from Etabs. Now I'm following the ACI code detailing requirement. Although this is not a part of course, as we are only focusing on how to do the things, the designing procedure in Etabs. But additionally, in order to give you the guidelines how to design the procedure for the slabs following FIM method and the ACI code properly, I have given this demonstration that following ACI code we provided 0.3 ln at least for this reinforcement, because this reinforcement is greater than 50% of the overall mesh. As the mesh reinforcement is 0.188, this number is 0.188, while your extra reinforcement is 1.0285. So this number is greater than 50% of this number. So that is why it was not following the ACI code if we provided the extent just following the Etabs extent, which was 132 inches plus 12 dB 12 dB. So that's why we provided minimum reinforcement from ACI code following 0.3 ln, which was much higher than this number, which is 132 inches plus ACI code dB requirement. So that is how we detail reinforcement following FEM method. Let's go to direction number 2. Direction number 2 is exactly the same. The only difference is your reinforcement would be in this direction. The reinforcement will be in this direction. However, rest of the procedure remains same. Similarly, for the bottom direction one would be this horizontal reinforcement, and the bottom direction 2 would be the vertical reinforcement. For simplification, I'll add the reinforcement here. Please note that this is a top reinforcement, so the bar should be in hidden line. I'll change the big layer. Okay, so the top reinforcement bar is always shown by a hidden line because it's above the mid depth of the slab. And the bottom reinforcement, I'll just draw for demonstration purposes. This will be your top reinforcement in direction number 2, and the design procedure would be exactly the same the way which we used for this reinforcement. This is top reinforcement direction number 2. I'll mention it for clarity. Please note that I repeat that this bar is just for demonstration purposes. The design procedure and to calculate the anchorage, development length and the number of bars would be exact same as I did for this bar, and this bar we did the calculation for in detail. So this bar, the vertical bar which I am drawing just to show the direction of the reinforcement, don't take it that this length and everything is already calculated. This length and the extent of the bar and everything you will calculate on the same way I have calculated for this horizontal top reinforcement. Now for the bottom reinforcement, your bottom reinforcement would be something like this. This is direction 1, and for direction 2, this is your bottom reinforcement. I'm circling this one. It means this is your exercise to calculate. Calculate by yourself. This is your exercise. I'm attaching the model and everything in the lecture.
If you are also looking for professional certified structural engineering services or courses, then don't forget to check link in description of this video.